Thanks everybody for coming. I got a mic here, so I gotta stay planted. I normally am a walker, so. Today's talk, we're gonna talk about why developers should care about container security. My name's Eric Smalling. I am a senior developer advocate at Snyk. We are a developer-focused security scanning company. I focus on containers, although we do scanning for lots of other things. This really isn't much about Snyk, really. Just to give you a background on what I do. I'm a coder by background. Was about a 20-year or so software developer in the travel industry in North Texas. After that, for the last decade, I've been doing consulting, mainly around what we would call DevOps, build automation, test automation. I started using Docker back in the early days, 2013-ish, back in like a version, I think I put version 06 before we had Compose, before we had Swarm, before we had Kubernetes. Since then, I'm a Docker captain. I have the normal CK whatever certifications that people get when they do consulting around Kubernetes. And I'm Eric Smalling on socials if you care. So the agenda for today, what we're going to talk about first is DevOps, and I have verses on this. I probably should change that. It's more DevOps and security. We see it almost adversarially sometimes, and it shouldn't be. And we'll get into that. Then we're going to talk directly about the topic at hand. Container challenges, especially from the point of view of developers. What is it as a developer we need to care about that you might not know about around containers? Some of this may be review for you guys, but I'll try to make it broad enough to cover most skill sets. And then I'm getting into the meat of this, which is a demonstration. I'm going to show you what can happen if you're not caring about security. We're going to show a vulnerability being exploited in an actual open source module or framework. And then we'll get to some conclusions, some mitigation effort ideas, and some things that to take away from this that you can use, hopefully, as you get into containers. So DevOps, it's kind of, it's one of these terms that some people think it's great, some people think it's a buzzword, some people think it's something to sell to you, some people think it's a tool, but really it's all about developer and operations working together. And it's often represented when you talk about code pipelines, continuous delivery, and all of those buzzwords. And those are usually represented like this, with a left to right pipeline software delivery lifecycle with ideation and coding on one side, going all the way down to production on the other. I've added our little Snyk logo, our dog, his name Patch, in areas that we historically see security applied. We've always had security, pretty much always had security at the production side of the house. You've always had things like firewalls and passwords and tripwires and all sorts of things at the production side to keep your systems away from hackers. That's kind of table stakes. 20 years ago we were doing that. As things progressed, we started applying security practices and processes into our pipelines, into our CD pipelines. Usually these were late stage. These were things that a security team would have a gate at some point. They would do an audit. They might have automated tools to do this, but they usually happen late because they took a while. They weren't something that you could just fire off at willy-nilly. They took overnight sometimes. Sometimes there was licensing on, if they were using automation that only ran on specific nodes in your CI servers. But it was a late thing, and often it was a spreadsheet or a report that they would hand back over the wall to the development team, and they probably checked in the code that introduced that vulnerability weeks ago. So you're out of context. What we've seen through progression of the years is security starting to move left. So years ago, when containers started coming in, we saw the registries start to add their own vulnerability scanners. Right as you put an image into it, at some point in time, a scanner will kick off and run and generate a list of vulnerabilities that are potentially in that image. Also in the code repositories that started offering the ability to have other kinds of scanning added as you're doing your commits and your pushes and whatnot. Automated tests started seeing security added to it. So you have your Selenium tests, your functional tests, your whatever you might have on a given pull request if you're in a Git style repository. Security could get added there. You could start seeing linters showing up and other policy related security tools. But the holy grail is to get security across the board and to get it as far left as possible, where it can be used by developers as part of their day-to-day, and the developers want to use it. And this really gets to the gist of the DevSecOps terminology you may or may not have heard. This is, security should always have been part of your DevOps process. And it's not that security didn't want to be there, but often those of us who are doing just software development, we didn't invite them to our little party. The iterative development cycle didn't go well with those long-term audits and tools, so we couldn't do it right away. So we're going to get into how does that apply in containers now. Well, as a developer, coming to containers new, you're increasing your scope of responsibility. There are things that, I was a Java developer for many years and a C developer before that. I know all about writing, or hopefully know all about writing well-formed code, sanitizing my inputs, doing things that are the right thing to do for my code. I also know about my libraries that I'm pulling in. I need to be pulling them from trusted sources. Well, most likely my company had a repository that they vetted, whatnot. We're not going to get into that side of the house right now. What containers added were things that I'm not maybe an expert in. Things like operating system controls, packages that come in as part of apt or RPM or APK, operating system distributions themselves. The base images of these containers come with file systems that are could be based on Debian or Alpine or whatever. And honestly, a lot of us have a lack of expertise around that. It's not something we do as a job. Now, if you came up as a Linux admin, it's probably second nature to you, some of these things. But many of us weren't, and we've had to learn it on the job. And while you're doing all this, and you want to start having security policies to help you, or security tooling to help you mitigate those issues or make sure you're not introducing expanded vulnerability sets, you want to choose policies and processes and tools that maintain the velocity that we're trying to get to with the whole continuous delivery process. You don't want to introduce a tool that is going to slow things down more than it did before, because the business is going to be like, well, what are you doing? You're doing it wrong. So when writing code, we have apps, and if you're in a you have services, apps, whatever you are deploying. What are they made of? So the first piece we know about, as I mentioned before, is your source code. You need to write clean source code. You know about those dependencies I mentioned. So this is it's kind of hard to read on this projector, sorry, but that's an example of just a requirements text file for a Python app. It's pulling in Flask RESTful, and PS utility. So those are modules I'm pulling in. I need to make sure they're good. But now we have these Dockerfiles. And again, I apologize if that's hard to read, but we've got a Dockerfile that is defining the image for a container to run from. And here, this is starting with Python 3. Okay, well, Python 3 what? What distribution is that on top of? How do I know these things? apt-get is being run then, and we're doing an update, and then we're installing stress-ng. Do I know what that is? Do I need that in production? Do I not? And then other things are happening, so we're defining our image in this language of the Dockerfile. And then on top of that, you may have infrastructure as code. This is a snippet of a Terraform file. So now you're codifying your infrastructure that everything runs on. The granddaddy in the container world of IAC files are the Kubernetes YAML. So if you love YAML, Kubernetes will give you tons, and that API is going to change on you three times a year as they add new features to it and deprecate things out of it. So how do you know you're doing the right thing about how to wire up your pods and containers and whatnot? And by the way, I apologize that these things are not coming gray on this. I will have the slides available to you at the end. I've got a URL you can get them from. So they'll be easy to read. So all that can make you hyperventilate just trying to get the app to work, regardless of whether it's secure or not. So enough of these slides. Let's get into the demonstration I promised. So I have an application, and we're going to set the stage here. Let's say you're at a company that has a legacy Java application, a JEE application that has been paying the bills for a long time. It's one of these things that's in kind of a steady state maintenance mode. You're not doing a lot of changes to it. And at some point, we decided, okay, we're going to deploy this thing on top of Kubernetes to take advantage of the simplicity of having a single deployment artifact that is the image and putting it out onto a Kubernetes cluster. So we just lifted and shifted it. We put it into a container, and we're running it out there. This is not uncommon. So what we have here is a Docker file to build our Tomcat-based Java app. This is a multi-stage Docker file. If you're not familiar with a multi-stage, you've got two from lines. There's one at the top and one in the middle on line 13. What that means is we're going to do something from Maven 3 at the top. We're going to build our app in this case, build our web app. And then the second from, the last from in a multi-stage Docker file is the one that's going to be the final image that is going to be produced, and you're going to push it to a registry and end up deploying it. So we're starting from the official Tomcat 8.5.21. It's a hella old version of Tomcat if you know Tomcat, but if it ain't broke, don't fix it is our policy, right? We want to, this is what we were running when we lifted and shifted, and it works, and we don't want to rock the boat. We want to make sure it still works. So we start from that point, we copy in a config file and then some artifacts from the stage above. You see the copy from build. That build is a token you'll see at the top on the as line. So we're saying copy from the first stage, the build stage, all the artifacts of the build, right? So we end up with an image that is Tomcat plus our configs plus our app, all right? Now I'm running that locally because I don't want to tempt the demo gods on having a cluster out there somewhere running this. So I'm just running Docker Compose, nothing fancy here, just running it locally on my laptop. And if I go refresh this page, just going to the top level context, you'll see there's the Tomcat default manager page with its info. If I go to the app itself, there it is. It's our wonderful to-do list app, which makes us tons of money and we don't want to mess with, so we're going there. But actually, the thing that's vulnerable here is not the app. Let me change hats here. Let me put on the hacker black hat for a moment. Let's say I am interested in looking for vulnerabilities in common web frameworks like Tomcat, app servers. Apache has a nice page here, which is the Tomcat 8, let me grow that font a little, Tomcat 8 vulnerability fixes over time. And you can see there are a lot of them. And I'm not, to save time, I'm not going to scroll through a lot of these. I'm going to jump to one. There's a certain kind of exploit called a remote code execution exploit, and it's just like it sounds. It's executing code remotely. So as a bad actor, I want to run something else besides what is the app remotely on your server. I see that they fixed this in Tomcat 8.5.23, and I could dig into this. We go to the Snyk vulnerability database. This is a kind of an expanded version of what you would see in MITRE. It's got a bunch of overview of what the vulnerability was, how it came in, what versions it was fixed in. It also has a bunch of other references, and a couple of those, I could dig into this and I could figure it out myself. However, there's a couple of exploit DB links, and one of them is this. This is a Python proof of concept script that will investigate any given web endpoint, any HTTP endpoint, and determine whether or not it's vulnerable to that CVE, which is the one we saw earlier. It has a couple stages to it. I'm going to show you how that works. So I've taken that Python script and I've wrapped it in an alias and put it in a own little container called check. And I've already configured this to point to my laptop's IP. You can imagine this being on some kind of like the old school war dialer, going through, just pinging away at IP addresses, looking for anybody listening that might respond with the result that shows that it could be exploitable. And I pointed it directly at mine to save time rather than scanning a network and looking for me, because I know where I am. It has said, hey, it looks like this server is vulnerable. So if I go back to my browser now, if I go to this, and instead of going to my app, I'm going to change this to poc.jsp. I promise you that this page with a bunch of A's on it was not there 10 seconds ago. What that exploit has done is injected a Java server page, a JSP, into that Tomcat web server. Now, A's are not very nefarious, but the fact that I could push it is not good. So I'm going to go back to that script and run the other side of it, which is pwn. And now I've got sitting here, it's at the bottom of the screen, it says uploading web shell. So I'm going to type, who am I? That says I'm root. What this is doing is it's connecting to the remote code execution exploit point. It has uploaded the JSP that can run execs on the server. In fact, if I go back to the website, I can see that JSP because it's kind of friendly, relatively. If I go to pwn.jsp, I got a nice little form. So I'll run who am I here. I'm root. So what this tells me is inside wherever the server, I don't even know if I'm in a container at this point. I just know that I have exploited, I have gotten to where I can run a command inside. So if I do a host name, for instance, there's the generated host name that this server had. This is running alongside the Tomcat server in the same environment it's running in. In fact, I could pull an env and I can see my environment variables. So this is the environment as it was loaded by the JVM, because we're just execing out of that JVM. And hopefully there's no credentials in those environmental variables, because if there were, they're mine now. Let's see what else I can do. Let's do an ls on etc pass wd. Oops, not ls. Cat on etc pass wd. Sure enough, I can see that. So now this is that interesting, because everything's, not really, there's nothing really secret here, except for all the usernames that are on this server. But I want to know a little bit more about this. So let's see, let's see, let's do a PS. Let's see if, I'm on the fly right now. I've not done some of these things. That doesn't output, yeah, that's not standard out. So let's do apt get update, yes. Oh, come on, demo gods, work for me. Oh, I refreshed it, I waited too soon. So there we go. Now, apt-get doesn't put everything out to standard out, so I'm not seeing the entire output here, but this is telling me, hey, I'm root on whatever this is, and I have access to app repositories. In fact, these are the internet-based ones, which is handy to know. Let's see if I can do other things. Let's see if I can HTTP Google. Hey, I've got curl. I've got curl at my disposal, and I got a 301, which tells me I probably did connect to Google, because it's trying to redirect me back to, like, a regional one in HTTPS link or whatever. So all this information I'm gathering as a hacker, I've gotten in, I've done all this stuff. I could go farther, but you can see how bad this could get. At this point, I probably am just going and downloading a script from somewhere and starting to Bitcoin mine or do something on your node and stealing it away from you. Now, through other investigation, I could probably figure out that I'm in a container. Now, that means I am not necessarily on the host, but I am UID 0 in this container, which is allowing me to do the apt-get installs. It's allowing me to get at things. Another thing I like to test would be, let's touch etc foo, and then do an ls ltr on etc. Scroll to the bottom. There's foo created just now. So I have a read-write file system, root file system available to me, so I can mutate this file system. I could probably get into the Tomcat's configurations, look for JDBC connection strings, modify your app. If I get into your class files, I know what I'm doing, I can mess with things. So hopefully, as I showed on the first slide, that little icon over the production side, you've got intrusion detection things going off right now, because there are people doing things on, or there's things doing things on a host that shouldn't be happening, connections that are being made that shouldn't be happening. So hopefully you're reacting to this, but it would be better to proactively have avoided this vulnerability altogether. So let's take a look at what you can do to avoid this even getting to production. Let me kill out of that. So I'm going to kill my Docker Compose session, and just to make sure everything's clean, I'm going to do an RM. This will delete my container and make sure it's not there. So I'm going to run, I'm using Snyk's tools here because I work for Snyk, and obviously I'm going to use my own tools, but container scanners will go in and look at your container image. Let me do this, I'll talk while it runs. So I'm going to do, actually, I probably have this in my history, Snyk, container test. So I know that I built this image as Java goof :orig. And the syntax of the Snyk test tool is, I'm saying Snyk container test, we do other kinds of testing, something container test, that image, which can either be a local image or it could be something out on Docker Hub or wherever, and you'll pull it if it doesn't have it. And I'm also feeding it, I have the Docker file that built that image, so I'm feeding that as metadata to give it a little more info so it can map layers a little easier. So I'm going to kick that off, and what container scanners do generally is they will rip through the file system of the image. An image is basically just a big tarbile with some metadata attached to it. But it's ripping through the file system that's in there and looking at the packages installed by whatever tooling, whether it be apt or RPM or APK, looking for versions of libraries that are installed, and then it's querying our vulnerability database now and looking to see, are these things up to date, are there vulnerabilities in them, so on and so forth. They do other things. They do file some level of file fingerprinting depending on the scanner you're using and what arguments you feed it. But in this case, when it's all done, you can see there's a huge list, like all of them give you, there's a huge list of vulnerabilities. At the bottom, though, what I like on our tool is that we feed you the summary at the bottom. So we have total 228 dependencies were found. That's the dependency tree of all the packages that it found. And it detected that I am on Tomcat 8521 base image. And that just coming along for the ride gives me 735 vulnerabilities just by using that base image. 70 of them critical, and our RCE should be one of those criticals. And all the, you can see the rest, the numbers there. Additionally, it's saying, you know, if you would upgrade to, I believe this is the latest 8.5 version, 8.579, that would drop your vuln counts quite a bit, down to 8 critical. Now, that's not great. It's still vulnerabilities, but it's a much more manageable size. And then we've got other ideas. You can go to Tomcat 10, I guess 10.1. You get 0 criticals and just some highs and mediums. And then there's alternatives like the, every time I run this is different because the vulnerability database is constantly changing. So right now, one of the best ones looks like Tomcat 10 on JDK 11 with the Turmarin focal build. So this is all using a specific version of the JDK plus a specific distribution of Linux. And that one has only 16 total vulnerabilities. Now, all that being said, let's say I am a junior developer. I don't know jack about operating systems. I don't know anything about JVM 8 versus 11. I just know how to work on my application. I can look at this and at least have an educated discussion now with my leads or my security analysts. I can say, hey, what should we do here? It looks like we should at least do some kind of upgrade because we've got a ton of vulnerabilities here and this is bad. And I'll put on my architect tab like, well, we can't go to 10 because we have our app is too old and it can't work with Tomcat 10. But 8.579 makes a lot of sense. And through other tooling, I can take a look at what these vulnerabilities are. We could prioritize fixing them or see if we have mitigations for what's left and so forth. So let's do that. Let's go to 8.579. We're going to try to click this. Copy this, go back to my editor, and I could just type that 8.579, save, and come back to my shell. Hello, and I'm just going to run Docker compose with a build command. That just tells it to do a Docker build before it ships. Should already be cached, should come up pretty fast. Let's make sure this works. Here, I'm going to go back to the top level of my server, get a 404. And but we do see Apache Tomcat 8.579 in the footer, so we know that the upgrade took on my local machine. We're getting a 404 because if you look through the history of the fixes, Apache wisely took that management thing out of the default production image because you don't really want that in your production image. That happens to be where the RCE was, actually. It was pushing through the admin panel. So now if I try to go back to, well, actually I should probably be a good developer. I should go to my to-do list app, make sure it still runs. Hey, there it is. Yay, so app's good. We would do our testing, push it up, we fix our problem. But to catch this early on, whether it be on my workstation or at least in a CI, like during the pull request process before it gets out, imagine if this wasn't a legacy app. Imagine if this was just something I'm developing and I've upgraded or I've pulled in a new base image for whatever reason. I'm trying out this other one. Having a scanner that I can tell before I've even committed it that it's bad and knowing about a better one to choose would be I think, very helpful. But let's just make sure we actually did fix the problem. So if I can find the right window, go back over here, and we'll run our check alias again. Not vulnerable. So the POC says, nah, I can't hack that, so move on to the next person. So that was contrived, I get it, but that was an actual RCE that was in Tomcat. This can happen to you. So let's skip through some slides here. This kind of goes, I don't know if you've probably seen the DevOps feedback loop. This is a graphic a lot of DevOps slides will have. The point being your pipeline is not finite. There are vulnerabilities always coming up. You want to make sure that you're always watching to see what new things come up. Just because you're sticking on something that just works, it just works today, but if a vulnerability is found in it, you need to know and be either repetitively scanning or running a tool that will alert you to that fact should a vulnerability come up in something you've already built. That being said, catching vulnerabilities that are known is one problem. Stopping vulnerabilities that are zero-day or not known, so let's rewind back a year, and let's imagine you're running a Java app and you have log4j in it. It wasn't really a 0 day, but it was damn close. It was a 0 day for about this long. But it was a quick fix. We needed to fix things really fast. However, if you practice defense in depth, you can head off and make life hard for hackers when they have such vulnerabilities. And I'm going to focus on, with the time I have left, 3 areas: your images, the runtime for your containers, and then we'll talk some Kubernetes, because that's where most people are running their containers now anyway. So when you build images, you want to make sure you minimize the footprint. Don't give hackers more tools to expand their exploits. You don't want, for instance, curl was in there. Why was curl in? Does my app really need curl? Probably not. It probably also doesn't need half the things that were in that Tomcat image. There are versions of images that have a slim tag on them that are good options to choose from. In fact, many of the recommendations you'll see from our tool will say, hey, take a look at the slim image, because there's many less tools packaged in. And you can see it in the size. You go from like a gigabyte image down to 400 megabyte or something. There's also other distributions like Alpine. Alpine is an interesting one. It's not a glibc based distribution. It uses muscle C, or however you pronounce that. But it may be great for you because it's made for small footprint and thus has less things in it that could be attacked. And then there's Distrolist, which is a Google open source project has put a set of images called Distrolist, which is very pared down. There's not even a package manager or a shell in it. They install everything with a package manager and then they rip everything out of it and then boil that down to the smallest image you could probably have starting. There's interesting things happening right now with a company called ChainGuard that is putting out some of their own images that are Distrolist-like, and they have an open source project, undistro they call it, called Wolfie. I don't have any slides on it because it's pretty new, but it's worth looking into. But anyway, just don't give hackers tools to expand their exploits. Understand how layers work. So if you're new to containers, you don't know an image is made up of layers. When you looked at that Dockerfile, roughly every line as it completes builds a new layer on top of the other. So think of it almost kind of like a Git repository where a commit is the delta between what you did and what was there before. Layers are kind of like the same thing. And when you run the container, it's going to bring those all together and present a unified file system to the process running in the container. Just understand that if you wanted to get curl out of that example I gave, just doing a run rm curl from a line in the Dockerfile isn't really sufficient. It will remove it from what the process sees. However, if somebody were to break into that container and let's say for some reason somebody ran that container with a bind mount to the host file system, if I can get into var run containerd or var run docker, I can find the layers. I can find the layer that still has curl in it and use those tools. So understand how layers work. We showed a multi-stage build strategy. Those are great. Multi-stage is a great tool. If you're using Dockerfile to build your images, which most people are, you probably should be looking at multi-stage. Most people are. They put it out in 2017, so it's not new. There's a lot of other things that I have no time to get into, but repeatable builds, being able to build the same image over and over. This is this is an onion, the amount of layers that you can get to try to get here, but there are lots of tools. One of the things that you can do that is somewhat repeatable is when you choose an image, don't just choose, like at the beginning I had that screenshot with Python 3. You don't know what that is. That's going to change every time you build with the newest version of Python. That is great for a developer. That is great for if your company, if you have CD that's pushing out multiple times a day or at least once a day, maybe that'll work for you because you're going to get the latest thing, you're going to get your fixes right away. Go for it. A lot of companies, however, can't release that fast. And pinning to a version allows you to have a predictive build, so you know you're going to get that version, at least that the tag is pointing to, every time you do that build. This is a religious war with some people I know. Some people think, no, you should always build the latest. I'm like, if your organization can do that, go for it. Some organizations just can't handle that speed. So pinning at least gives you the ability to know what you're going to get out of it. But if you're going to pin, make sure you have a scanner so you know what's in that and you know that it's time to upgrade. There's other things like standardized labeling. You can add metadata to your image. That's interesting. Get into that later. And there's alternative tools. I actually gave a talk recently on Jib and Go, which are, Jib is a 100% Java implementation of a image builder that right from your Maven or Gradle, you can build an image. You don't even need a container runtime engine. You don't need Docker at all. It just builds an image and it does it with best practice as per the open source community around it. Go has Co, which is a very similar kind of a tool. It does a few other fancy things that I can't get into here. And then finally, secure supply chain. There are literally conferences around secure supply chain nowadays. When I bring it up here, I'm not going to get into the minutia of it. I just want to make sure you know where your images come from, know where those base images are coming from. Don't just be willy-nilly pulling things off the internet as part of your CI process. Also, only CI or some automated process that's auditable should be building your images. Eric, building an image on my laptop, should never be able to push that to anything that's going to get deployed, because you have no audit around that. You have no idea where that it came from. Even if I sign the image with Sigstore tools and whatnot, you're still trusting human. Human makes mistake. Use robots. At least they log their mistakes. Finally, at runtime, we want to practice defense in depth here in that things like, you saw that I was running as the root user in the container. You probably don't need to do that. Most applications can run as a non-privileged user in a container and are just fine. Most, if not all, open source official images are set to default to root because they don't know what you're going to do with it. But they often will provide you a user that you can change to and run as. So the Tomcat user, or Tomcat image has, I believe, a nobody user in it that you can switch users to and run as that. It has the right access needed for its caching and whatnot, but it has read-only access for your application and other things in the image. Node, for instance, has a node user you can use. And you can do that either through the Dockerfile. You can say user and give it you should use the UID, not the name, for reasons we'll talk about in a minute. But you can switch that user so that the default when a container starts up will use that. But most people, honestly, in their Kubernetes YAML will specify, if you're being careful about this, you'll specify there what user you want it to run as. Read-only root file system. Oh, I'm sorry, I'm skipping. Privileged containers, you don't need this. Unless you're writing monitoring tools, like for Kubernetes, or network plugins, or things that are really low level that need access to host devices, don't do this. This is a privileged container, which on Docker is -- privileged. On Kubernetes, security context privilege equal true. If you do that, you're giving the process in the container access to host devices. They can mount volumes, they basically own the box. In fact, I was talking to the creator of that feature in Docker, Jerome Peterzoni, and he joked with me, he said, yeah, we thought about calling that flag -- insecure, because it totally is. So unless you have specific need or you're installing a specific tool from a vendor that has a reason to do this, it's highly dangerous. Linux capabilities are interesting. You can, when a container starts up, it gets a certain set of capabilities, Linux capabilities for system calls it may need to make. And the folks at Docker and Containerd and Red Hat at Cryo have kind of whittled that down to a common set that most applications can run with. However, a lot of business applications, if you're not running low-level network tools and whatnot, don't even need all of those. In fact, many can run with no capabilities at all. You can drop them all. There's a command, there's a setting in the security context, capabilities deny all. And your app just won't be able to do things like access the network stack at a low level. It won't get netcat add, or a lot of capabilities that you just don't need. There are tools like Tracy, Falco, and other things. Is it 5 minutes? Oh, no worries. No worries. Code. No worries. Code 1010, folks. No worries. There's tools like Tracy, Falco, and other things that you can use strace that you can figure out what capabilities your app might need. But look into that. You read about it. It's important. Back on track. Read-only root file system. We saw that I was able to edit files. So immutability is one of our 12 factors. We should be writing microservice architectures immutable so that they can be easily orchestrated and moved around the cluster. But also because if I'm in there and I can modify things, I can cover my tracks. I can side load in new jar files. I can do all sorts of crazy things. By running read-only, what you're telling the container engine to do is don't install a read-write layer. Just use the immutable layers that you got from the image, and then every mutation that tries to happen will get a denied because it's read-only. This doesn't fix if you're mounting other volumes, so you need to pay attention to permissions when you do that. But it's just another step. Not a silver bullet, but it's another thing to make it life harder for a hacker. And then similar to the, before we know where your images are coming from, know where your sources for packages and everything, deploy only from known good sources. Okay, let's talk Kubernetes real quick. If you have credentials, JDBC connection strings, any kind of secret data, Kubernetes provides you a secrets object. If you're not using some other kind of application secret management tool like HashiCorp Vault, CyberArk, or things like that, that you already have libraries for and you're using anyway, keep using those if you are. They're great tools, whatever. But if you're just needing a credential and you need it just along with your app and you don't have those tools, don't just put it in the image. That's horrible. That's like putting it into your GitHub repository. It's visible to anybody that can pull that image. Don't put it in a config map. Those are not encrypted in any way. Secrets are a separate object, just like a config map. That's a key value pair. You can put data in them. You can put up to, I forget the size. Is it a meg now? I don't remember the size you can put in there. But you put keys in there, you put all sorts of stuff in there, and you can put separate RBAC on it from your config maps. So you want to have role-based access control on it to make sure that only the service accounts for your applications that need them get them, as well as talk to your operators of your clusters, especially if you're in a on-prem cluster that they built themselves. Secrets are stored in etcd. They're stored in free text, base64 encoded, not encrypted, unless the cluster operator has specifically set that up. Now, if you're in a managed cluster, like in the cloud, you probably have that because that's the default, is they're going to have encrypted secrets at rest. But make sure that's set up. Role-based access control, or RBAC, kind of self-explanatory. You should use it. If you don't know it, learn it. It's important because you don't want to give everybody access to everything. Security contexts are, much of the things I talked about in the last slide and others are implementable by the security context, which is an API on top of pods and the containers in them. Network policy, I didn't talk about this earlier, but network policy is available to you in most Kubernetes clusters via the CNI, the Container Network Interface plugin provider, unless you're on Flannel, which doesn't have network policy. A lot of developers like myself, when we first look at network policy, we shy away from it because that's firewalling, that's network, that's not anything I know how to do. Network policy, once you learn it, it's really not that difficult. It's basically a declarative definition of what you want talking in your deployments. So your pods, what pods can talk to each other, and it uses labels to do it. So if you've got say you've got a front end and a back end to your application, you can specify nobody talks to anybody except front end can talk to back end only and on TCP port, whatever. But that way, if somebody were to exploit a front end server, they couldn't get it back and forth between the front ends if you didn't want them to. If they got into a back end server, they couldn't reach forward and start messing around with the front end. All that kind of weird traffic. For instance, the Log4j, Log4Shell exploit last year happened because you convinced the Java, logging system to call out to an LDAP server. Well, if you have network policy in place that says you can only talk on these certain things, that LDAP server probably wouldn't have been able to be called. So that would have been a good stopgap mitigation until you could patch your servers. So network policy is your friend. Learn it, love it. And finally, all of the things I'm talking about in Kubernetes can be enforced with tools. Now, there has been historically pod security policy for things like the security context. That has been deprecated, and in fact, it has been removed as of Kubernetes 125, which went live, a month and a half ago. You're still going to see it because many people are not on 125. In fact, you'll probably see it for 2 more years while people upgrade. It is replaced by a variety of things. There's pod security admission, and it replaces much of what was in PSP, but the most common things I see are admission controllers like Gatekeeper, which is the OPA admission controller, if you're familiar with OPA, that's a Rego-based policy system, and Kyverno is another very popular one. There's others. But these are tools that you can install in your Kubernetes cluster that apply policy at the API server as requests come in. They can deny them based on the policy or approve them. They can also mutate them, so you could say always set read-only file system true on every deployment. You really are brave. And it will mutate the pods to all have that as it flows through. It does other things than that, but that's the main point, is to enforce the policies for all the things we've been talking about. So the key takeaways from all of this, and we might have a couple minutes for questions, is you want to have a fast feedback loop first. You want to make sure that whatever you're putting in place just like your unit tests. It's fast and actionable, and that it empowers you to be productive. You want tooling and processes that are going to give information to your developers or yourself that if it's something you don't know about, it at least gives you a starting point to learn about it and fix it proactively, rather than waiting for an exploit to happen in production or for a late-term audit to put it on your backlog to get work someday. And finally, practice defense in depth. Do things that should an exploit happen, or when an exploit happens, when an incident happens, you reduce the ability for that bad actor to expand, get a beachhead, start doing things to your servers. So you want to make it so that you want to make life hard on them. So thank you. I know this is very small, and on that it's illegible, so I made you that. That will take you to that link, or that QR code will take you to the slide share of this whole deck, including all of these links. These links are things like, we have a security context cheat sheet that my colleague Matt and I wrote to walk you through the 10 most commonly used security contexts in Kubernetes, Dockerfile best practices and multi-stage build instructions from the Docker folks, pages for OPA Gatekeeper and Kyverno, a nice blog that the SIG security folks did on why they deprecated PSPs and the future for that, and a couple other things, including some videos I've done on security context.